You are welcome to Best Brain Academy. My name is Dr. Kingsley. Please do subscribe to my videos. Now, I have a question for you on thermodynamics, the first law of thermodynamics. Let us look at the board. The question says, an ideal gas absorbs 600 joules of heat while expanding. During this expansion, it does 400 joules of work. After that, it is compressed by 100 joules of work and 200 joules of heat is released. Calculate the total change in internal energy of the gas after both processes. So from this question we can see we have two processes, expansion and compression. Okay, look at this very well. When you look at this, that is the first process, that is for expansion. So we have a gas absorbs 600 joules of energy. Remember, heat absorbed, okay, is positive. That means Q is equals to 600 joules for the first process. Then, during this, it does 400 joules of work. When a work is done by a gas, the work is positive. That means our work, okay, is also positive, which is 400 joules. Remember, our formula, change in internal energy for that process becomes Q minus what? W. Okay, that is a change in internal energy is equals to Q minus W. That means that what? Our change in internal energy will become, okay, Q, which is 600 minus W. W is what? Positive, so it is a 400. Remember, it's positive. So when we have this, our dE will become equals to 600 minus 400 will give us 200 joules. Okay, internal energy is 200 joules. Now let us come to the second process. The second process says after that it is compressed by 100 joules of work. Now look at here, compression by, okay, 100 joules of work and 200 joules of heat was released. Now heat now is released. So heat is released by what? By this gas in the second process. Remember, the heat that is released, or when a gas releases heat, the heat, which is Q, is negative. So if you release 200 joules of heat, then the heat should be negative, which is 200 joules of heat that is released according to the sign convention. Remember, when you absorb heat, when a gas absorbs heat, okay, the heat is positive. When a gas releases heat, the heat is negative. Okay, when a gas does a work, the work is positive. When a gas, okay, a work is done on a gas by compression, okay, the work is negative. So we are having compression here. That means that what? Work is done. So work is done on the gas. Work is done on the gas. So work done on a gas is negative. So we should be having minus 100 joules of work. Then change in internal energy will become equals to heat minus work. Okay, that means that change in internal energy will become heat, which is what? Minus 200. Okay, minus what is our work? Our work is negative, minus 100. Okay, that will give us what? 200. Okay, minus 200. This is negative, minus 200. Okay, plus 100. So change in internal energy become equals to 100 what? Joules. Okay, that is a minus 100 joules. Okay, that is a, okay, minus 100 joules. We have here minus 100 joules. Now, but they ask us to find the total internal energy. Okay, we know that what? The total internal energy, okay, total will be internal energy for the first process, which is a E1, okay, plus the internal energy for the second process, which is a E2. That will be equals to what? 200, okay? 200 plus minus 100. And that will give us what? 100 joules as the total change in internal energy. Remember, the first internal energy, okay, increases because it's greater than 0. The second internal energy, okay, decreases because it's less than 0. But the total internal energy, the final, okay, increases because it is positive. Please subscribe to my video, my channel. Please subscribe to my channel and also share my video and like them. Wait until I post another one. Thank you.